Hello, and welcome to this presentation on Gaussian elimination. We're going to solve linear simultaneous equations using the Gauss method. The Gauss method of elimination. The three simultaneous equations shown below can be solved for the three unknowns stated as x1, x2 and x3 using the Gaussian elimination method. So in the first equation we have a11 multiplied by x1 plus a12 multiplied by x2 plus a13 multiplied by x3, and that's equal to b1. I've called that equation 1. The a's are called the coefficients, they're the numbers, and the x are the unknown variables. We have a second equation designated as coefficient a21 multiplied by x1 plus a22 multiplied by x2 plus a23 multiplied by x3, and that's equal to b2, and that's equation 2. We have the same form for the third equation with a31 multiplied by x1 plus a32 multiplied by x2 plus a33 multiplied by x3, that's equal to b3, and that's called equation 3. To solve these equations using the Gauss method involves operations that change the coefficients, that's the a terms above, in the second and third rows, and so reducing the equations into a triangular form. So using the Gaussian elimination method, we'll end up with three equations to solve for the three unknowns, x1, x2 and x3, in the format of equation 1, which is given to us in the original question, equation 1 dash we will get by the elimination process, and equation 1 double dash also found by the elimination process. From equation 1 double dash we will find the value of x3, we will put the value of x3 into equation 1 dash, and we'll find x2, and we'll put the values of x2 and x3 into equation 1, and we'll find the value of x1. So these xn values, in this case x1, x2 and x3, are obtained for what are called the pivotal equations, and 1 dash and 1 double dash are called pivotal equations. You'll see how they're derived in the examples we're going to review later in the presentation. So the table on this slide shows the Gaussian procedure required when solving three linear simultaneous equations. Step 1. We're going to rearrange the equations so that all the variables, that's the x terms, are on the left hand side and all the constants, the pure numbers, are on the right hand side. This gives the equations 1, 2 and 3. Step 2. We're now going to determine equation 1 dash, which is equation 2 minus the coefficient a21 divided by the coefficient a11 multiplied by equation 1. We're then going to determine equation 2 dash, which is equal to equation 3 minus the coefficient a31 divided by the coefficient a11, again multiplied by equation 1. What has been achieved in step 2 is a reduction in the number of equations. We now reduce the original 3 equations down to 2 equations. In step 3 we're going to find equation 1 double dash, and that's equal to equation 2 dash minus the coefficient a dash 32 divided by the coefficient a dash 22. We multiply that by equation 1 dash. Step 4. So by transposing now, the value of x3 can be obtained from equation 1 double dash, that's a pivotal equation. We can then determine the value of x2 by back substituting the value of x3 into equation 1 dash, it's another pivotal equation, and rearrange it. And finally we can determine the value of x1 by back substituting both x2 and x3 values into equation 1, the original equation given in the question, and rearrange it. There is a step 5 we can undertake within this Gaussian elimination process, and that's a checking procedure, sometimes called the row sum check. This allows us to verify our calculations as we go through the Gaussian elimination, ensuring we hopefully don't make a mistake in the calculations. The following slide shows examples of how to apply the procedure shown in this table. Example 1. We're going to solve 3 simultaneous equations shown below using the Gaussian elimination method. So the first equation is 2x1 plus 3x2 plus 4x3 is equal to 12. The second equation is x1 plus 2x2 plus 3x3 is equal to 9. And the third equation is 3x1 plus 4x2 plus 6x3 is equal to 19. On the right hand side here, I've just repeated the generic formats of the equations from the previous slide for reference. So equations 1, 2, 3 in generic form, showing the coefficients, the a11, the a12, etc., and the constants on the right hand side, the b1, b2, etc. We'll be referring to some of these coefficients in the solution shown below. So in the table below, we've got the equation on the left hand side, equations 1, 2 and 3. We've got the x1 coefficients, x2 coefficients, x3 coefficients, and b is the constants on the right hand side, and the b dash column shown here is what we use for the row sum check. I'll show you how that's used as we progress the solution. So now let's consider equation 1. This is called a pivotal equation. What I'm going to do is write down the coefficients associated with x1, x2 and x3 for equation 1. So from the information given in the question, we've got 2x1, so the coefficient is 2, plus the 3x2, so 3 for x2, plus the 4x3, the 4 in the x3 column, and that's equal to, on the right hand side, 12 for the constant. The b dash column is simply the sum of the coefficients for x1, x2, x3 and the constant. So adding 2 to 3 to 4 to 12, we get 21. Now considering the second equation given, and don't forget there is a 1 here, we don't write the 1s, but there's actually a 1 in that position. So writing equation 2, we've got 1 x1, so it's my 1, we've got plus 2 x2 plus 3 x3, and then we've got that equal to, on the right hand side, 9. Again, summating the x1, x2, x3 coefficients with the constant b, we get 1 plus 2 plus 3 plus 9 is equal to 15. And finally, looking at the equation 3 here, this is the coefficients now for equation 3. For x1, that will be 3. For x2, that is 4. For x3, coefficient is 6, and the constant on the right hand side is 19. If we sum 3, 4, 6 and 19, we get 32. So now we've taken all the coefficients and the constants from the given equations and put them into our tabular form, and we've added our row sum check, the b dash column. What we're going to do now in the process is eliminate the x1 variable from equations 2 and 3. So we'll reduce the number of equations from 3 initially given to 2 equations. So now we're going to generate what's known as pivotal equation 1 dash. To do this, we're going to consider equation 2, and we're going to take from equation 2 a factored equation 1. And the factor we're going to use is coefficient a21, shown here in our generic equation format, and we're going to divide that by the coefficient a11, again shown here in our generic form. So in this particular case, the a21 coefficient is 1, so there's the 1, and the a11 coefficient is 2 in this case, so there's the 2 used. So basically it's equation 2 take away a half multiplied by equation 1. So we're going to apply that to all the columns, the x1, the x2 and x3, as we go through our process of elimination. So let's now apply this equation to the above tabulated coefficients. So equation 2 coefficient for x1 is 1, and equation 1 coefficient for x1 is 2. So following our format through of equation 2 is 1 minus a half times equation 1, so a half of 2 is 1, so that will be 1 take away 1, that will give us a value of 0. So that's how we get the 0 value here. So again, that's equation 2 coefficient, which is 1, subtract a half of equation 1 coefficient, so that'll be a half times 2, so that'll be 1 take away 1. Considering the x2 column now, the coefficient in equation 2 is 2, and we're subtracting from that a half multiplied by the equation 1 coefficient, which is 3. So 2 minus a half multiplied by 3, that's 2 minus 1.5, that gives us the value of 0.5. Considering the coefficients for x3, equation 2, that will be 3, and we're going to subtract from that a half multiplied by the coefficient for equation 1, so that's 4. So 3 take away a half times 4, 3 take away 2, that gives a value of 1. And now for the constant, B column, we've now got 9, the constant on the right hand side for equation 2, and we're going to subtract from that a half of the 12, the constant in equation 1, so 9 take away 6 will give us a value of 3 in our 1 dash equation. Now consider the row sum check, the B dash column in equation 2, that's 15, and we're going to subtract from that a half of 21, so half of 21 is 10.5. So 15 subtract 10.5 gives us a value of 4.5. So now we can apply the row sum check to equation 1 dash. If we add up 0.5, 1 and 3, we get 4.5, and that's the value in the B dash column. So this shows that our arithmetic at this stage is correct. We're now going to generate the equation 2 dash, and we apply a very similar principle here. It's just that we use equation 3. So the coefficient A31, shown here generically, will be a value of 3 in this particular case. So that's the 3 we're using in the factor. Coefficient A11, used before, will be 2, and that's shown here in our equation. So now to find equation 2 dash, it's equation 3 take away 3 upon 2 multiplied by equation 1, or basically equation 3 take away 1.5 multiplied by equation 1. So now we're going to generate equation 2 dash. So equation 3 subtract 1.5 times equation 1. So equation 3 coefficient for x1 is 3, and we're subtracting from that 1.5 times the coefficient for x1 in equation 1. So 3 take away 1.5 times 2 will actually give us a value of 0. So for equation 2 dash, the value here is 0. So we repeat the process now for the other columns. So for x2, the coefficient for x2 in equation 3 is 4, and we're subtracting from that 1.5 multiplied by the coefficient of 3 for x2 in equation 1. So 4 take away 1.5 multiplied by 3, that's 4 take away 4.5, gives us a value of negative 0.5. For x3, the coefficient in equation 3 is 6, and we subtract from that 1.5 times the x3 coefficient in equation 1. So 6 take away 1.5 times 4 is basically 6 take away 6, so that's where we get a value of 0 here. For our B column, we've got now the constant of 19 in equation 3, and we're subtracting from that 1.5 times the constant B for equation 1. So 19 take away 1.5 times 12, that's 19 take away 18, gives us a value of 1. Now for our B dash column, we've got 32 for B dash in equation 3, and we're going to subtract from that 1.5 multiplied by the 21, the B dash value in equation 1. So 32 take away 1.5 times 21, that's 32 take away 31.5, that gives us a value of 0.5. We can now undertake our row sum check. So we've got negative 0.5 plus 1 gives us positive 0.5, and that's the value in the B dash column. So again, our arithmetic seems to be correct. So now with the Gaussian process, we've eliminated one equation. We've now got two equations to deal with, 1 dash and 2 dash. We now need to go through the process one more time to reduce the number of equations down to 1, and from there we'll be able to solve for our unknowns x1, x2 and x3. So next we're going to eliminate the x2 variable from the equation 2 dash. So to find equation 1 double dash, the next pivotal equation, we will use equation 2 dash, and from it we will subtract a factor multiplied by equation 1 dash. The factor we will use here will be the x2 coefficient for equation 2 dash, so that's negative 0.5, shown here, and we'll divide that by the x2 coefficient for the 1 dash equation of 0.5, and that's shown here. We could simplify this to equation 2 dash plus equation 1 dash, because we've got double negatives and also 0.5 divided by 0.5 which is 1. So the solution we require here simplifies to equation 2 dash plus equation 1 dash. So considering the x3 coefficients, we've got 0 for equation 2 dash x3 coefficient, and we've got 1 for equation 1 dash x3 coefficient. So now equation 2 dash, which is 0, plus equation 1 dash, which is 1, gives us a value of 1. For the B column, the constant is 1 for equation 2 dash, and we're adding to that the constant of 3 from equation 1 dash. So that gives us a value of 4 for the equation 1 double dash. Now applying our solution to the B dash column, we've got 0.5, and we're adding to that 4.5, so we find that we get a value of 5 for the B dash column. Again, we can check the values for equation 1 dash. If we add, in this case, the 1 to the 4, we get 5, which is correct. So again, our arithmetic seems correct. What we're going to do on the next slide is, first of all, using equation 1 double dash, solve for the unknown x3, and use pivotal equation 1 dash, rearrange that and solve for x2, and then use equation 1, the original equation given, rearrange that and find the x1 value. Example 1 continued. We're now going to solve for the unknowns, the x1, x2 and x3, using the pivotal equations 1 double dash, 1 dash and 1. So what I've done here in the table below, I've listed the values for the various pivotal equations. We've taken equation 1 double dash, the x3 coefficient was 1 and the constant b was 4. We get that from the previous slide. For the 1 double dash pivotal equation, the x3 coefficient was 1 and the b value was 4. So we have an equation here of 1x3 is equal to 4, so obviously x3 is 4. So we found the first of the unknowns, x3. Now using pivotal equation 1 dash, we get the coefficient for x2 is 0.5, coefficient for x3 is 1, and the constant b is 3. Again, that's from the previous slide. For equation 1 dash is our coefficients 0.5 for x2, 1 for x3, and a constant of 3. That gives us an equation of 0.5x2 plus x3 is equal to 3. So simply rearranging the equation to find x2, I subtract x3 from both sides of the equation and divide by 0.5. So x2 is equal to 3, take away the x3, which is 4 from above, and that's all divided by 0.5. So we find that the x2 value is negative 2. And finally, from pivotal equation 1, first equation given to us, we've got an x1 coefficient of 2, an x2 coefficient of 3, an x3 coefficient of 4, and a constant of 12. And that's what we saw from the previous slide. This was the equation given originally, pivotal equation 1, x1 was coefficient of 2, x2 coefficient of 3, x3 coefficient of 4, and the constant b 12. So forming an equation, it's 2x1 plus 3x2 plus 4x3 is equal to 12. So rearranging the equation for x1, we take away 3x2 from both sides, we take away 4x3 from both sides, and then we divide throughout by 2. So x1 is equal to 12, take away 4 times 4, 4 being the x3 there, take away 3 multiplied by negative 2, and that's the x2, and it's all divided by 2. So that gives us a value of 1 for x1. So now we're going to check our solutions by solving the equations, but this time substituting the value of b dash from the previous slide for the value of b. So considering pivotal equation 1 double dash, we know that the x3 coefficient is 1, but the b dash value now will be 5, and we get that from the previous slide. Here's the b dash value for equation 1 double dash. Evaluating for x3, we find that x3 is equal to 5. So if our values for x3, x2 and x1 are 1 more than that found above in the previous table, then we have the correct numerical solutions, and it is because the value in the previous table is 4 for x3 and we have a value of 5 now, so that's 1 more. So we must have our numerical solutions correct. If we now take the pivotal to the equation 1 dash, we know the x2 coefficient is 0.5, the x3 is 1, and the b dash value is 4.5 from the previous slide. Here's the 4.5 value from the previous slide for b dash of equation 1 dash. Again, rearranging for x2, we find the answer is going to be -1, and again that's 1 more than what's found in the above table, -2 here, so that must be correct. Finally, using equation 1, the x1 coefficient is 2, the x2 coefficient is 3, the x3 coefficient is 4, and the b dash value is 21. Here it is on the previous slide, the 21. Again, rearranging for x1, we find that x1 has a value of 2, and that's 1 more than that found in the above table here, which was 1. So again, numerically, that must be correct. So now we found the value of x1 is 1, x2 is -2, and x3 is equal to 4. So we've solved the 3 equations using the Gaussian elimination process. Example 2. We're asked to solve the following 2 simultaneous equations using Gaussian elimination. The first equation is given as 4v1 minus 3v2, and that's equal to 18. And the second equation is v1 plus 2v2, and that's equal to -1. On the right hand side here, I've just shown the generic notation for equations 1 and 2 with the a coefficients on the left hand side and the b constants on the right hand side. In this case, the x1 and x2 are v1 and v2. The v variables could be for voltage or velocity, depends on the context of the question. So as with the previous example, the first thing we're going to do is write the above equations in tabular format. We have equation on the left hand side, then v1, v2, b, and also b dash columns. So for equation 1, we have 4v1 minus 3v2 is equal to 18 on the right hand side. Remember, the b dash column is used for the row sum check, and is basically the summation of the v1 coefficient, v2 coefficient, and b constant. So in this case, the b dash column is going to be 4, take away 3, add 18, and that gives the value of 19 in the b dash column. And now considering equation 2, don't forget there is a 1 in front of the v1 that we do not write, but it's there. So we have 1 v1 plus 2 v2 is equal to -1 on the right hand side. Again, to find the b dash column, we simply add the 1 to the 2 and take away 1. That gives us a value of 2 in the b dash column. Continuing our process, we need to eliminate the unknown v1 in this case from equation 2 above, producing the next pivotal equation 1 dash. So what we're going to do now is consider equation 2 and subtract from it a factored equation 1. The factor in this case will be found from coefficient a21, which in this case will be 1, shown here, divided by the coefficient a11, which is 4 in our case, and it's shown here. So essentially what we have is equation 2, and we're going to subtract from that a quarter of equation 1, or in decimals 0.25 multiplied by equation 1. We're generating equation 1 dash here, which will eliminate the v1 from the equation 2. If we consider the coefficient for equation 2 for v2, that's 2, and we're going to subtract from that the 0.25 multiplied by the coefficient for v2 in equation 1. So we're going to subtract from this -3 multiplied by 0.25. Typing that into the calculator, you find we get a value of 2.75. Now consider our B column. We've got -1 on the right hand side for equation 2, and we're subtracting from that 0.25 times the 18 in equation 1. Evaluating that gives us -5.5. If we now consider our B dash column, we have 2 for equation 2, and we're subtracting from that 0.25 multiplied by 19, and that gives a value of -2.75. We can check the B dash column by adding these two terms together. 2.75 minus 5.5 does indeed give us -2.75. So our arithmetic is correct. So we're going to solve for our unknowns using the pivotal equations. First of all, 1 dash and then 1. So for the pivotal equation 1 dash, we have the 2.75 coefficient for the V2, and that's equal to the -5.5 for the B. So we can rearrange that equation. -5.5 divided by 2.75 will give us the value of V2. In this case, that's -2. And now to find unknown V1, we're going to use the pivotal equation 1, repeated here, and that's 4V1 minus 3V2 is equal to 18. Rearranging for V1, that becomes 18 minus 3 multiplied by 2, be careful negative sign there, all divided by 4, and that gives a value of 3. So we found that V1 is equal to 3 and V2 is equal to -2. We can now check our solutions by solving the equations, but this time substituting the B dash values above for the B column. So for equation 1 dash, we have 2.75 again for the V2, but this time instead of having the -5.5, we'll have the -2.75 for the B dash value. Solving for V2, we get a value this time of -1, which is 1 greater than that shown above, so that's correct numerically. Finally, using pivotal equation 1, shown above here, repeated below for convenience, we've got 4V1 minus 3V2 is equal to, this time, 19. We're using this value for the B dash column. Again, rearranging, V1 is equal to 4. We can see that's 1 greater than that shown above for V1. So again, numerically, we have the correct solution. So finally, we can say with some confidence that V1 is equal to 3 and V2 is equal to -2. Here are some tutorial exercises. I would strongly encourage you to stop the presentation now and attempt these exercises. Solutions to be undertaken using Gaussian Elimination. Exercise 1 is a solution for two unknowns, V1 and V2 in this case. Answer on the right hand side in brackets. Exercise 2 wants us to solve three unknowns. That will be X, Y and Z in this case. Again, the answer is shown in the square bracket. And exercise 3 wants us to find four unknowns, X1, X2, X3 and X4. And again, the solution is shown in the bracket. Exercise 1 solution. We're solving for the unknowns V1 and V2. We've got two equations to solve here using Gaussian Elimination. I'll let you review the solutions. Two pivotal equations, 1 and 1 dash, were generated, and these were used to solve for the unknowns. V2 is 2.4 and V1 is 4.2. Exercise 1 solution continued. This is the check solutions, substituting the value of B dash for B. Again, we find the solutions here for V2 is 1 greater than that found on the previous slide, and the same for V1. It's 1 greater than that on the previous slide. So our solutions is V1 is equal to 4.2 and V2 is 2.4. Exercise 2 solution, we're solving for the X, Y and Z variables here. I'll let you review the solution at your own pace. Exercise 2 solution, we're finding the values for Z, shown here, for Y, shown here, and for X, shown here. We've got our check solutions for reference also shown.
Exercise 3 has 4 simultaneous equations with 4 unknowns x1, x2, x3 and x4. So we have to generate 4 pivotal equations, 1, 1 dash, 1 double dash and 1 triple dash. I'll let you review this solution at your own pace.
Exercise 3 continued. We've worked out the values. X4 is 1, X3 is 2, X2 is 3 and X1 is 4. We've also done the check calculations here, substituting B dash for B. We find that each of the values calculated for X1, X2, X3 and X4 are 1 greater than that shown above. Finally, some tutorial questions for you to attempt. Question 1, 3 unknowns S, V and A. Question 2 here has 3 unknowns, is a current in a circuit I1, I2 and I3. Solution is shown in the brackets on the right hand side. Tutorial questions continued. Question 3 has 3 unknowns, x double dot, x dot and x. X double dot stands for acceleration, x dot stands for velocity and x is displacement. And question 4, we have an x, a y, a z and also a h in this particular case. Relates to a portrait frame analysis. Tutorial questions continued. I'll leave you with question 5, has 4 unknowns, x1, x2, x3 and x4. Answers shown here in brackets. Here's the bibliography used to help generate this presentation for your reference. I hope this presentation has been of interest to you and thank you for viewing.